Good afternoon, everybody. Just like the previous speaker, Anthony, I'm talking about really a disruptive technology in the aviation field. And maybe it's the biggest step since the jet engine, really. But it's got some challenges. And this program, ASTRAEA, I'm going to talk about. I'm not going to dematerialize the acronym because we've long since forgotten what it stood for. But it's something about autonomous systems is the first two letters. So I'm going to talk a little bit about, why is it important, particularly to the UK aerospace industry, and then look at what the market is and what are some of the challenges that we face, and why autonomous systems is the key to solving this, rising to this opportunity rather than solving the problem. So the aerospace market is pretty important in the UK. It's probably not so well known that it is the UK is the second largest aerospace country in the world. It employs a huge number of people, both directly and indirectly, and spends an awful lot on R&D, and is clearly a lot to do with sort of high-value skills and things. So it's fairly valued by government. And rather like the electronics industry, this program has goes back to the innovation and growth teams that were from the last government in the early 2000s. And so there was an aerospace innovation and growth team, just as there was an electronics one. And subsequently, and with this current government, there's an aerospace growth partnership being formed, which is the equivalent of ESCO for the electronics industry. And so there are parallels there. What's the market about? Well, it's a slight conundrum, really, in one respect, is that until one solves the problem of accessing the airspace, which is what ASTRAEA is all about, is the market really doesn't exist because you can't do it. But thinking about what you can do with it, and the real sort of criteria or the real advantage of unmanned aircraft are endurance. Because you're not carrying a person on board this aircraft, endurance is not an issue. And indeed, the environment in which you're flying is not an issue, in that you can take risks as well that you wouldn't do with manned aircraft. So there are two sort of real advantages of unmanned aircraft. People do talk a bit about economics, and for maybe very small ones, there's an economic case as well. But it's far from proven that that's so for larger unmanned aircraft. But I think it's doing things which you can't currently do with manned aircraft, are the real attractions of this. And so, in the papers has been the unfortunate accident of the Malaysian aircraft. And it's a fairly good example of where the search and rescue teams that have been trying to find the debris is they've spent most of their flight endurance time actually getting to the search area and only been able to spend a short time there. Well, you could have stuck an unmanned aircraft up if you had the means of refueling it and all the rest of it for a week or two, and you'd risk it in poor conditions and everything else, and then you'd be able to target manned aircraft if necessary to go and look precisely where you needed to. And very high risk things like firefighting. My favourite is always the environmental monitoring and the Eyjafjallajökull volcano there in Iceland that went up and disrupted air travel because nobody was brave enough to go and measure the ash, so you could have sent an unmanned aircraft up for it. But as you'll probably sort of read in the newspapers most recently, there's Google buying, and it was mentioned earlier today, buying up technology companies, and one is about putting up effectively low-cost satellites, unmanned aircraft, to do communication relays, and Amazon and delivering their books to your door. But it's great hype, but until we've solved some of these problems, they're not actually going to be able to do it. And so the market will develop when we've made the airspace accessible. Now, there is small unmanned aircraft, in fact, can and do operate, and in the UK you require a license to do what's called aerial work from the CAA, but I think it's got probably to about 250 organisations, operations have licenses today, and it's been growing at a sort of exponential rate. And so for doing things like sort of small-scale agricultural monitoring, there are all sorts of uses. Estate agents use them to take photographs of houses. I mean, you know, another good example, I think, is about on oil rigs, inspecting the flare stack on an oil rig. I mean, normally the way they do it is, I understand, they have to shut down the oil rig, and some poor soul has to climb up a ladder and peer down the stack, which is not a very pleasant task, and of course quite disruptive. Whereas you can set a small little unmanned aircraft with a high definition camera up there and do it much more simply and easily. But the problem with those is the rules, certainly in the UK and adopted by most countries, is that they can only fly within direct line of sight of the pilot on the ground. They have to be under 400 foot of altitude, so they can't interfere with manned aircraft, other airspace users. And they're not allowed within closer than 50 meters to any person or building. So it's really quite restrictive. But you can see, if one could solve the airspace access problems for this, they'd be quite useful. And, you know, things like delivering transplant organs, you know, currently they go up on the back of a motorcycle, so from St Thomas's in London up to Leeds Royal Infirmary or whatever, but sending it in a small UAV you can see as being a really quite practical and useful thing to do. Whether delivering your parcels to your door on your third floor flat in Clapham or something is actually practical is only time will tell. But the challenge that we face is that all the regulations for manned flight or for flight has been based on the fact there's a pilot on board, and they've developed over the last 100 years or so, and the pilot's there with the ultimate responsibility of the safe conduct of that flight. And so obvious things like seeing and avoiding other air users, or they might be assisted in some parts of the airspace by air traffic controllers, for instance, but ultimately the pilot is responsible for avoiding others. They clearly have to communicate with air traffic controllers. They're there to monitor the health of the aircraft and overall its safe conduct. And the problem is the regulations as written, I mean, there is no interpretation of how you would transfer those regulations to unmanned aircraft. As industry, we would like to know what the regulations are before we spend money on developing product. The regulators quite sensibly put it the other way around. Well, you show us a product and we'll tell you whether it's safe or not. So we've actually got to sort out the technologies and the regulations in parallel to sort out how we take the pilot from the aircraft to the ground. And again, for the moment, the assumption is there will always be a responsible person on the ground, a pilot on the ground looking after this air vehicle. But they won't be in the same direct control that a pilot is on board the aircraft. But the regulators have been sort of helpful to a degree in that they've made two very simple statements basically about transparency and equivalent. And so they'd be happy as long as we can demonstrate that it's transparent to the system, and so it will behave in the same way that other airspace users, manned aircraft do. It will follow the same instructions that they will. and it will operate in an equivalent way and be at least as safe as the equivalent manned platform. The UK has actually been fairly advanced in thinking about this, although we've been way behind in terms of developing military UAVs. Israel and the States have been way ahead of us, but the Civil Aviation Authority in the UK came up with a document on the right there, CAP 722, about 10 years ago, and it's internationally recognised as about the best piece of work on the guidance for introducing unmanned aircraft into airspace. And I mean, although we talk about access to airspace, the CAA will say, well, the airspace is there for you to use. All you've got to do is prove to us that you're safe and capable of using it. So back in 2006, the ASTRAEA program was formed, and it has some very simple but really quite challenging aims, which was to enable the routine use of unmanned aircraft, or drones as the popular press likes to call them, in all classes of airspace, so anywhere in airspace, without putting any special restrictions or special conditions on their operations. And the program is about developing and demonstrating those technologies and how you'd operate them, and working with the regulators as to how the regulatory framework needs to develop to do that. Oh, and that's what the acronym stands for. So it was formed in 2006, and basically 7 sort of major UK companies, or 6 major UK companies and an SME AOS, part funded, half funded by those companies and half by the public sector. When it was first formed, it was the DTI, Scottish Enterprise, the Welsh Government, and 3 English regional development agencies. Things have changed since then, and so we've now got the Technology Strategy Board has taken on much of that. And it's involved at least 100 other companies and universities in the work it's done to date, and has worked very closely with the Civil Aviation Authority. The concept, and it is fairly unique, and we don't believe there's another program in the world that is really trying to tackle the total system problem. And it's basically, you've got your unmanned aircraft is understanding the whole flight from the moment the engines are switched on, which is when the pilot takes control and ownership of that aircraft in law, taking off, flying en route, avoiding other air users, avoiding terrain, avoiding areas where you're not allowed to fly, etc. And so it's the whole operation, and also looking at some of the softer issues about legislation, insurance, and public perception, which is an issue in it. So just looking at why autonomous systems. Military aircraft, the military UAVs, are in fact relatively simple in that they are more remotely piloted vehicles, and they're flown in segregated airspace, effectively, where other air users are excluded. And therefore, they are not facing the problems that we are in trying to introduce civil unmanned aircraft into all airspace. And so we've got to sort of bring some intelligence onto the platform, and I'll try and explain that in a bit more detail. The complexity is we can't take all of the pilot senses. I mean, a pilot on board an aircraft not only sees, but feels and smells and hears things. All his or her senses are being used in the piloting of that aircraft. And therefore, to sense everything and send all that information down to the ground would require huge bandwidth if you were doing it in real time, and wouldn't be practical really to do. And we've also got to look after the case where inevitably you will lose that link. And then this air vehicle has got to behave just as a manned aircraft would operate, follow the rules of the air, operate entirely safely under those conditions. And therefore, we have to move some of the intelligence of the pilot onto the air vehicle. And if we're to take advantage of things like the endurance of it, we're going to have to be able to refuel this thing in the air as well, which is quite a complex task, is air-to-air refueling. I mean, a lot of people have talked about autonomous systems recently, but I guess it's one of those rather ambiguous words, and it's rather a pity we maybe picked up on using the term autonomous to start with, is because this has got to be highly predictable if it's going to get through a certification system. And so, I mean, the proper definition of autonomy is it doesn't have sort of much human intervention in it. And so what we're not talking about is unthinking drones. We're not talking about something that's irrational and unpredictable. And we're certainly not talking about something that wakes itself up in the morning, opens the hangar's doors, goes off and does something, and then comes home and parks itself in the evening. And the CAA in CAP 722, has made and highlighted in red, is that it's got to be a rational system that makes, equivalent decisions, basically. Now, the application of this we see as very much is not about a fixed level autonomy, but variable autonomy. And there's there are various ways that people have used to explain this. This is a so-called the PACT scale, the Pilot Authorization and Control Task, which runs from where sort of the pilot has full authority and the unmanned aircraft has none, all the way down to the opposite end. And in fact, I mean, taking a very simple example is if the aircraft is flying, it detects something which it thinks is going to interfere with its flight path, and other aircraft say, it would send a message down to the ground to the pilot saying, I'm a bit worried, what shall I do? If the aircraft doesn't receive a reply to that, the pilot's gone off to have a cup of coffee, or or the comms link is lost, then it will say, raise it up a level and say, right, I haven't heard from you. I'm now going to take this turn in 20 seconds unless you tell me not to. And if it fails to receive a message back on that, it will then just undertake the maneuver. So it's this concept of variable autonomy is the way we see autonomy operating. We had to create a functional block diagram, an architecture for doing this. I mean, one of the interesting things, and you won't be able to read it all in detail here, but the color coding here is showing that some bits really aren't affected by turning it into an unmanned aircraft. A lot of the functions of an aircraft are just the same as a manned aircraft. Some had to be modified. Some, like an onboard see and avoid or detect and avoid systems, are new systems that we've got to add. On the phases of ASTRAEA we've done to date, the most recent phase we've went into sort of 4 major technology programs, and I'll very briefly just touch on those. I mean, we called one autonomy and decision making, but that really pervades through the whole program, because it's all about moving a level of intelligence onto the vehicle. And so, and the major bit is the integrated mission system, and that's going to be the difficult bit to clear through the certification authorities. But clearly things like air-to-air refueling, being more frugal about our use of power and things like that. And one of the interesting things is almost all the technologies we've been developing will feed back into manned aviation, because they will make it more efficient, it will make it even further degrees of safety, and certainly degrees of security as well. And so one of the exploitation routes for all of this work is going to go directly and probably first into manned aviation. One of the interesting things is this whole human system interaction bit, because we can't give all the information that's on the aircraft down to the ground, is this whole handshake about what does the ground pilot really need to know, and how is the ground pilot going to interact with air traffic control, etc. And so latency is, in messages, is quite an issue here. And so we've done quite a lot of simulation work with air traffic controllers, and we recently flew a surrogate aircraft. It had pilots on board for safety reasons, but was flown by a ground pilot up from the northwest of England up to the north of Scotland to just understand what the effects of this latency has been. And certainly in low traffic conditions, it's not a problem. But if you were trying to fly one of these things out of Heathrow, it would be a real problem. And so there are things that we've yet to solve. Communications, although is something that people don't talk enough about, I think. To me, this is the hardest problem we've got, is how do you have a high integrity communication system that is totally secure, or as near as you could possibly make it totally secure, and without having to put a huge infrastructure in place. And using satellite communications is not the practical answer. I mean, you can use it, but it's expensive, and it's, you know, we can fly a few UAVs that way. We're never going to fly huge numbers. And so we've been looking at ad hoc communication systems relaying from other aircraft in the sky as ways of doing that. Detect and avoid is the thing that everyone talks about, is how do you see other air users that could be parachutists, balloons, gliders. They're not just big airlines. And we've done a lot of work, a lot of flight trials, again, using surrogate aircraft. And in fact, some very promising results using video cameras and clever algorithms at being able to perform at least as well as a pilot. But you've also got to see weather, because if you're flying under visual flight rules, you can't fly into clouds, so you've got to be able to see, detect clouds and maneuver away from them. So there are lots of things. And also, if you're going to have to make an emergency landing, you've got to be satisfied that where you're going to land is free of living people. One of the interesting innovations that we did was a virtual certification system. And it was a clever idea, really, in really trying to look at the total system and make sure we'd covered all the bases here, is that we took a well-known manned aircraft, a Jetstream 31, in which all the certification paperwork was available. And we took that paperwork and laboriously, all of the paperwork you needed, we modified the pages that needed modification. We added new pages where there were new systems like detect and avoid, and through the technologies we developed, passed it to the CAA, who went through this, and this brought some real understanding both to the regulator and to ourselves as to everything you needed to tackle, and came up with some quite surprising results. But again, it's a pretty unique activity at having done that. So where are we going next? We've gone a long way. We've got to around TRL 5 or 6, but we've not really got all the way there. Europe, EASA, the European Aviation Safety Organization, has produced a roadmap, as the states have, the FAA, which is looking to sort of initial operations around about 2018-ish and further sort of into the 2020s. We've just started a small program, ASTRAEA 3A that we call it, that's looking at continuing to work with the regulators and developing further the virtual certification activity. And we're in the process of bidding for a second program, which is looking at really demonstrating and validating all the technologies that we've done and flying actual UAVs to prove the case. And it's really about trying to get keep the UK ahead, because we think we are ahead in our understanding of this at the moment, and to actually accelerate the whole of Europe's ambitions in this area. And they're the sort of things that we're going to be doing. And including at the bottom there, you'll see about sort of virtual operations in terms of licensing and issues like public acceptance. And I mean, this has got to be an inclusive activity, and we've been talking with ESCO about, you know, because this is the whole supply chain that we need to involve in doing workshops and things like that to move this forward. So what are the challenges that I see left? Well, we're in a highly regulated environment, and we've got to prove by demonstrations. We're never going to prove anything just by paperwork and simulation. It is about international standardization, because there's no point just having a national solution to this. Aircraft fly across borders, so it has to be international. And as somebody was saying earlier this morning, standardization is the key there. So it's about the openness of getting standards sorted out. There is a big issue about public perception. They worry very much about, in fact, spies in the sky really is the concern. It's less about safety, interestingly. It seems to be much more about invasion of privacy, which we've got to address. The regulatory process, and I think our virtual certification thing, has applications elsewhere. It's a quite simple way of looking at regulation. And a lot of the technology advances that I think we're making, I see no reason why they can't transfer to other sectors as well. They're not just limited to the air sector. So that was a very rapid thing. You know, our motto is safe to fly and flown safely. Flown safely, can't even say it, yes. Thank you.